The BDR solution securely reads and processes HL7 data directly into FHIR with limited human intervention with the BDR graphical interface, nor does BDR use costly third-party application intervention or requirements. Let me show you how straightforward it is now that BDR has developed the solution that replaces years of mapping and development efforts your organization would otherwise need to complete, though complete with unknowingly ingesting the wrong data into many FHIR files and columns. BDR does this with its Spark, Java, Spring Boot framework, the same used by FHIR. For example, here is a database of HL7 messages that would be similar to messages you have in your data at rest files, or that you would receive from hospitals or healthcare providers in real time. Here we see a few of the many types of HL7 messages and what information they contain. Here we see patient, doctor, medicine, encounters, observations and other forms of healthcare information. Now we will demonstrate the ease and speed of BDR-FHIR as it performs many tasks, behind the scenes, to populate a FHIR database using raw HL7 messages as its data source. Initially you can see that the FHIR database is totally empty. We navigate to the BDR graphical interface to select the source of HL7 messages and the target FHIR server. The user will click on the source HL7 database, then select the target FHIR environment that will receive the FHIR transactions created by BDR-FHIR from the HL7 messages. The process is extremely straightforward. As you have seen so far, there is no need for technical knowledge of HL7 or FHIR. The final step is to just click on this Run button to start the process and let BDR's automation do the rest. BDR then reformats the HL7 data into JSON format as required by FHIR. BDR-FHIR then maps the HL7 fields to the appropriate FHIR fields. BDR knows how to process the approximately 37,000 fields in FHIR that have various data types, iterations and multiple occurrences. An example of this is a patient having several doctors and many prescriptions. The next behind-the-scenes processing step, and by far the most difficult, is accurately building what is known as a bundle. A bundle includes the HL7 JSON fields with the proper descriptions and identifiers as well as the target FHIR field. The FHIR server needs this information to be exactly correct to properly organize all this information so that a patient is properly connected to their doctors, and doctors and patients are properly connected to their prescriptions and treatments. Any flaws in constructing the bundle will cause information to be misplaced or lost. BDR automatically handles all the oppressively complex and error-prone tasks that your organization would otherwise need to complete. As we can see, the FHIR repository is populated. BDR-FHIR immediately encrypts the HL7 data to protect it from unwanted intruders. Don't worry, BDR-FHIR understands the internals of a FHIR server and will decrypt data when it is requested by an authorized user. For those with deeper understanding of FHIR, BDR uses the concept of FHIR interceptors to encrypt and decrypt data in the FHIR database. Now we are showing how you navigate to a BDR screen that lets you select data directly from the FHIR server with specialized BDR retrieval that is not capable with supplied FHIR API calls. Now let's request data to be displayed on the screen and downloaded by patients to meet the ONC Cures Act or others to migrate this data to other locations for analytics. A key feature of BDR-FHIR is its ability to seamlessly decrypt the data that had been encrypted in FHIR via FHIR interceptors and BDR decryption APIs and make it available for patients to download onto their phones, tablets or PCs, or for authorized users to view or extract onto their devices. This same process allows analysts and others to migrate these or any results from FHIR into other applications, databases or even data lakes and data warehouses. Here we are seeing the same data migrated to a Snowflake database, though the user could have selected most any RDBMS or data lake to migrate this data to. And we see BDR securely encrypted the migrated data. Now we are seeing all the same capabilities straight from HL7 messages that can be at rest in a database or HL7 messages from a hospital or healthcare facility in real time, and this data being used to meet the Cures Act for patient viewing and downloading as well as migration to other application databases or data lakes and data warehouses. There you have it. You have successfully built a fully encrypted FHIR server filled with data that meets interoperability requirements of the Cures Act by allowing patients, authorized healthcare professionals and analysts to view or simply extract data from the FHIR database.